Welcome to In the Loop, a New England Temperature Solutions podcast. Today, NET's president Dom DeLuca will be sitting down with Joe Pinsenault from Oxygon. With over 40 years' experience engineering and working on controlled atmosphere furnaces, Joe has seen and been part of many major materials advancements starting at the ground floor. Without further ado, here's Dom and Joe helping you get in the loop.
Hello, I want to welcome you to our podcast, In the Loop, today. And with me, I have a friend in the industry, Joe Pinsenault. Joe is from Oxygon, and we've known each other for a long time. And I want to thank you for being our first customer to join us today. Joe, could you share some stuff? Who are you, Joe?
Joe, well, first of all, thank you for having me. And I didn't realize we were your first customer. I mean, I have worked with you for a long time in the past. At a different company, but that was a long time ago. Uh-huh. But anyway, I'm Joe. I've been in the vacuum furnace industry for over 40 years. Cut my teeth right out of college, working in the industry as a draftsperson and worked my way up to engineering manager. And so it's been a real big ride. I've got 3 children, 2 grandchildren.
Wow.
I'm not married. I enjoy hiking, being outdoors. I'm a home brewer.
Oh, okay. There you go. There's another podcast coming. I can see that one. So you have 2 grandchildren?
2 grandchildren.
How old are they?
Oh, they're both 5. One's like 5.5, and the other one's almost 6.
Awesome.
Yeah.
Awesome.
Yeah.
Boy, girl,
both boys. Yeah.
Okay.
One's local. One lives in Florida.
Oh, wow. Yeah, that'd be tough.
But
that far
yeah,
away.
they're going to be up next weekend for vacation, so I'll get to see.
Awesome. And you live in New Hampshire?
New Hampshire, yeah. All my life, born there, raised there, worked there.
Okay. Cool. Yeah, New Hampshire's great. You have a nice, relaxed personality. People in New Hampshire tend to be a little more relaxed than people here. The traffic up there is not as intense. So you hike? Where have you hiked in New Hampshire?
Well, I've hiked a lot mostly in the White Mountains,
Okay.
Working on the 48, 4,000 footers.
You are? Okay, I was going to ask you that. That was going to be my questions. That's the thing.
I've got 39 so far.
Wow.
Yeah.
That's great.
Yeah. And
which one's left?
Oh, hard ones.
Hard ones. Yeah. Mount Washington? No. Have
No.
you done Mount Washington?
Yes, a few times. I've got the 2 northern presidentials left. I got Adams and Madison.
Okay. You've been to Liberty?
Been to Liberty. Been to Flume. Been to Lafayette. Did the whole Franconia Ridge.
Lafayette, actually, that's the one. I stayed in the hut, the Greenleaf hut on Lafayette. It's my only 4,000 footer, I think.
But I got the Tri-Pyramids to do, South Twin, Wildcats.
Wow.
Like I said, tough ones.
Yeah. No, that's awesome.
Yeah.
And have you ever thought about like hiking the Appalachian Trail or anything?
Oh, I have. And if I were to even consider it, it'd be sort of as a section hiker, not
right
through hiker.
Yeah, I did a section of it. I did, I think 2 miles in and 2 miles out.
Well, actually,
that's it.
A friend of mine that I hike with quite a bit. I hike with my son a little bit, and my brother, and a friend of mine. He actually adopted. We're AMC volunteers.
Oh, okay.
So we do trail maintenance. He adopted a trail, and I'm a co-adopter.
Oh, nice.
And we do 1.5 miles of, actually, it's part of the Appalachian Trail.
Wow.
Yeah.
For those of you who are serious about AMC, that was a joke that I did a section of it. I mean, I did it to say, oh, I did 1 mile of the Appalachian Trail. It was actually part of another trail that we went to. I think it was a falls off of 302, right before Crawford Notch, I think is where was where's the AMC on 302? What town is that? Just past the Wiley House.
Yeah, I don't know
Yeah,
what town.
that's
That's almost in Bartlett, I guess.
Yeah, well, my condo's in Bartlett. Technically, I pay Bartlett taxes. That area. So so it was a joke. I've never done anything. I've read several books on it. It sounds like an intense thing.
Yeah.
And
well, I mean, and I've been hiking a lot of times. I went hiking a few weeks ago. We're on top of Moosalok, and you can smell the thru hikers, right?
Yeah.
And I saw one, and they all have a trail name, so I always try to engage with them a little bit of conversation because they're alone quite a bit on the trail, right?
Right. Yeah.
Find out their trail name and
Right. Cool.
yeah.
The one I came out on, there were people there. It was a Saturday or Sunday morning, and they were serving donuts to the.
Yes.
And I
yeah.
didn't want. I felt squirrel. I only did.
Right.
I don't need
Yeah.
to take a donut.
Right.
So, you've been in the industry for 40 years.
Yeah.
Okay, that's awesome. And where did you start?
Well, I started at Centaur back in the 80s as a draftsman. I don't know. You're familiar with Centaur is a small vacuum furnace company. They primarily focused on research and development.
Right. Back in the day, they were small.
Yeah, back in the day when they first started. And I was there for 6 or 7 years. I graduated from mechanical draftsman to do electrical drafting, and
Okay.
I kind of got confused with electrical drafting because I didn't know what I was drawing, so I went to school to learn about
Okay.
industrial electricity, and so all of a sudden I understood what I was drawing
Mhm.
and tried to make improvements on the drawings, and at one point the electrical engineer at Centaur quit, and suddenly I was the electrical engineer.
Wow.
So I was doing that for a few years before they got consolidated with Vacuum Industries.
Okay. Yep. All right. And then from there, you moved. What is
From-
now across the street, right?
Essentially, yeah. I mean, I left there, went to materials research furnaces.
Okay.
Started there as the electrical engineer. Shortly after a few years, the engineering manager retired, and I was put in his position. So I was engineering manager for, I want to say, 31 years there.
Wow.
Yeah.
So you were an MRF for.
Yeah, I started there in 1990.
Wow.
Yeah.
Time flies. I would have, if somebody asked me how long they were around, I would have never guessed 31 years. But then
Yeah.
again, I'd never guessed that I had 64 either if I had to think about it quickly.
Well, they've been around longer because it's 24 now, right? So.
Right.
But,
Right.
yeah.
Yeah. So then you made the journey up the street.
Yeah, I had spent a lot of time at MRF, spent a lot of time building that company up, and got to a point where I needed a break,
Mm-hmm.
and I took a summer off,
Okay.
which was really great.
Oh, yeah.
I did a lot of hiking,
Oh, nice.
and then I couldn't afford to retire, still kind of young, so I ended up going back to work at Oxygon.
Okay. Yeah, my story about Oxygon I shared earlier. So yeah, not only are you the first customer we've had in the podcast here, but Oxygon back in the day, we used to make the loop. They had thermal technology. I'd go up to New Hampshire from Attleboro. I'd stop at Thermal Tech first, get on 28, right, and go to Centaur MRF, and then drive up the street to Oxygon. And at the time, every one of those vacuum furnace guys was Honeywell.
Right.
That's all they used, Honeywell. So I'd show up as the Barbara Coleman guy, and at the time, Eurotherm. By the time we had Eurotherm, we did business with them all. But when I was the Barbara Coleman guy, and Barbara Coleman was a no-name. But for some reason, Roger Ingerson invited me in at Oxygon. He's one of the founders, right?
Yes.
And he listened to me, which was unique, and he actually started buying some of my product, and which was unique, and I was forever grateful that I've never been able to get into that market. Now we do a lot with everybody because the products we have are very, used quite frequently in the industry. But Oxygon was the first vacuum furnace company in New England to actually give me a shot, and I was a young sales guy. I'd probably only been selling for two to 3 years, so that was kind of a good good thing in my life, a thing I remember, so I won't forget it. So
I think we were the first ones to buy a Kearsarge power supply too.
Oh, right, Kearsarge, right. That's actually how I heard about it. I was there, and you guys had this transformer, and I said, hey, where'd that come from? And you told me about Kearsarge, and we're now the Kearsarge this rep for several accounts in New England, and actually, there's a podcast with Kevin Shannon on it, and so no, that's great. That's really good, and you guys have. We had a former company we sold for infrared, and they fell on their face with your company, and I won't mention them. And I dumped the company because I said you don't mess with my customers, especially Oxygon. So you guys, I'd love to have them. If any of you guys are from other companies are watching and you want to have a chance to have a discussion, we'll be more than happy to invite you to sit in this chair. So Joe, we actually have well, first of all, let's talk about Oxygon. Do you want to say anything about what your elevator speech is and give a pitch?
Yeah, Oxygon, well, we're a small company. We build controlled atmosphere furnaces and gas purification furnaces. Small bunch of people. We have some people that are artisans at what they do. The work that they perform is just unbelievable. We're customer focused, customer driven. We're small enough that we don't have to worry about big corporate. We're family owned. Customer comes first, and we try very hard, and we do work very hard to make robust systems that are going to meet the customer's needs for years.
Well, you use our product, so you're top of the line,
right? Right.
And I love the name too. I mean, people have said to me, "What does Oxygon mean?" Oxygen gone. I mean, it's a much easier way to spell vacuum than. I was thinking this morning, and I was like, are there any other words in the English language that have two U's next to each other? And because I remember early on, like what? But there are. Conundrum was one, and there's one other one you might remember, but I already forgot it. I just looked it up. What? Continuum, right? Continuum and conundrum. Those are the two that you'd know. There's like 10, but Oxygon's a much easier way to spell it. We have a new engineer here from Northeastern. His name is Andy, and he's actually running this podcast. He's the guy behind all the equipment. And he had asked when he heard you were coming as how long you been out of college? 4 or 5 years?
3 years.
3 years, mechanical engineering. He's our technical guru. He handles our heaters and controllers and all that stuff. So he asked if he had a bunch of questions, and I thought it'd be cool to have Andy. He'll put his face on the TV here. There he is. Hi, Andy. And he's got some questions that he'd like to ask you about the vacuum furnace industry from a college, new engineering industry, which I thought would be cool because they look like some really cool questions. So I'm going to let Andy ask the questions, and he'll disappear because he's shy, and then give you a chance to answer the questions.
Sure.
Go ahead, Andy.
All right. So one of the questions I have is how have vacuum furnaces evolved over your career, the decades you've been in the industry? How has that evolved over time in terms of uses and construction of the furnaces?
Well, the construction of the furnaces in reality hasn't changed a whole lot. The fact of the matter is that high temperature materials are not very common, and so there's very few options. You have graphite and tungsten and moly and tantalum, and those are, for high temperature furnaces. And what I've been involved in is furnaces that really start at 1,000 degrees C and go up to 3,000 degrees C. Recently, 3,200 degrees C. And I've been higher in another instance, but that was a singular case. But so up until recently, materials really haven't changed in terms of what you use for heaters and the shields or the insulation. There have been slight nuances with some alloys or derivatives of those materials, but the biggest change that I've seen has been with the electronics. Those obviously have changed greatly over the last 40 years, from totally analog, potentiometers to make adjustments to, almost talking to the machine and having to do what you want, But yeah, I mean, that's really been the biggest difference.
Right.
And in some respects, it's kind of been the downfall, because electronics are somewhat, in certain industries or locales, are prone to failure, unlike some of the older technologies.
Right.
But
I've seen furnaces at some of these companies making parts that are very important, and they're using old controllers and that are still around. The new ones would never survive that long.
right, and some of the industries that I've been involved in, medical, for instance, once they qualify a process for a product, it's very difficult for them to change anything.
Right.
Very, very difficult.
Right. Well, good.
All right. Another question I have is, are there any products that are public facing that we just take for granted that require vacuum furnace technology to produce? Or is it more behind the scenes stuff, heavy industry?
Well, I mean, it is behind the scenes, but it's everything that we touch requires a vacuum furnace. Almost every electronic component or device that we have requires a vacuum furnace for one function or another. A lot of the passive electronic components are processed through vacuum furnaces. LEDs. And then even in automobiles, all the electronics in cars and brakes and engine parts, right? Because they're used for heat treating in a lot of cases, but they're used for sintering of materials, cleaning materials. So yeah, I mean, your toaster's got Bluetooth. Part of it's been put through a vacuum furnace.
Really? My toaster?
Yeah. Wow.
Yeah. Well, no, I know it's that ridiculous. My dishwasher has Wi-Fi. I'm like, who cares?
Right.
Yeah. Cool. And that's interesting. I never thought of that. And matter of fact, what I'm going to do right now is post-production. I'm going to put a picture of a vacuum furnace so people, who've never seen one, because they are big and they are. They can be dangerous. I mean, there have been issues where doors have flown off. And,
right.
Especially the ones that were pressurized.
Right.
But we talked about earlier, it's not necessarily a vacuum.
Yeah, vacuum, it's a broad term, right? For vacuum furnace is a broad term for really controlled atmosphere furnaces. So it can be vacuum or reducing atmospheres or pressure or inert gas.
And the unit of measurement for vacuum, and you can tell us because you worked at Centaur, is a torr, right? And the Centaur is that 10 to the minus torr? Is that what what does the Centaur stand for? 10 torr?
Centaur was the name of the company, right?
Right, but was it a play on
centigrade?
Oh, centigrade
and torr. So it's temperature and vacuum, right?
Oh, okay, I got that wrong.
So that was
a
great. And you remember the Centaur was their logo. The half man, half horse is a Centaur.
Oh, I did not know that.
Yeah, that was perfect. And just so you know, torr is equal to millimeters of mercury for those of you that are metrically preferred, I guess, per units.
I have trouble with my ski boots because I'm not metrically, and they're all in 41, 42. My foot's not. I mean, what's 41, 42?
So when you take your blood pressure, it's in...
Oh, I understand.
Millimeters of mercury, which is torr.
Oh, I take my blood pressure all the time. I know how to do my wife was a nurse. She taught me how to do the real one with the cuff and everything. So I didn't realize that. That's interesting. See, we're learning stuff all. So no, thank you. That's great. Andy, another question? Were you finished with that question?
I guess I don't remember
the question
you're fully, but I mean, it's such. Well, actually, there's one other thing that they're being used for today, and that is to literally print. If you break a bone or something in your body and potentially they need a replacement part for that, they can now 3D print those parts and sinter them in a vacuum furnace.
Wow. Well, I have some of those parts, and I'm due for another part. So, that's interesting.
And, they do it for two reasons. One is to sinter the part, I think, and I think that's the biggest reason. Another one is to try and make sure you kill any bacteria. that may
Right,
be in there.
sterilization. Yeah.
Right.
Yeah, and that would be more of a pressure.
Well, I think it depends on the application. I can't speak. I'm not try to stay away from processes as much as possible.
Sure.
Um,
Because autoclaves remind me a little of a vacuum. Matter of fact, they're similar in how they're constructed,
Right.
but they're pressurized,
Right.
and then they
Yeah.
take all the air out. So and they sterilize in a
Right.
autoclave.
in
So
a heated environment, yeah.
heated, right? So, and you said 32 to 35. We were asked recently. I don't know if it was you or not to go to 35. Actually, we've been asked to go higher than that, which is almost impossible in infrared. But it's a hard number to
That
get.
one, that pyrometer we were discussing will go to 4K
really 4,000. Yeah, well, 4,000 centigrade or 4,000 Kelvin.
centigrade.
Centigrade. Okay. Yeah. Cool. Yeah, and things are getting hotter the more
Yeah,
the materials, the alloys and stuff.
and I mentioned I had worked on a project where we went to over 3,500.
Wow.
We didn't know how high we went because the pyrometer went off scale. But, it took special equipment. It was a pressure furnace,
Right.
high pressure.
We had a similar situation. We were doing a test, and based on what happened in the furnace, we know we went above 3,500 because we went off scale too,
Yeah.
and it got all smoky and weird inside the window. So, Andy, another question.
Yeah. So practical like limitations of vacuum furnaces. We talked about how 3,500, 4,000 is about as high as they can go temperature wise. How about size constraints? What are the biggest parts you're throwing into one of these? How big can the furnaces get?
Well, again, we mentioned talking about vacuum as a controlled atmosphere, right? And some furnaces are continuous furnaces. They're open ends, but they're in a controlled environment. They're purged with argon or an inert gas. And they can get quite large. A furnace can get quite large. For a vacuum furnace, it's not really practical to get huge because it requires a lot of pumps and so forth to pump the chamber down. But in terms of the size of furnaces, I've seen them so big that you could almost put a train car in them.
Yeah.
They can get really big. And when you think about some of these components that are made by the government, like particle accelerators, lots of those are huge vacuum chambers, that are under vacuum. So it's really how much money you want to spend and how far you want to go.
Mm-hmm.
But in a practical sense, you probably don't want to get too big, maybe a meter cubed or, maybe twice that for vacuum.
So,
But I've been through a vacuum furnace. I've walked through one before. It was used to braise radiators for automobiles.
I know, you guys tend to be on you're not like the lab vacuum furnace, but although you
Well, we do a lot of laboratory type equipment.
Okay.
The sort of the logic is to try and help develop technology, right?
Mm-hmm.
And in essence, hopefully that'll be something available to us
Mm-hmm.
as something that we can sell to somebody else or scale it up.
Mm-hmm.
So I mean, it helps us, it helps the world because,
Right.
we're working with, leading edge technologies
Right.
all the time.
Right. Okay, so yours are on the smaller side. I've seen,
Yeah.
I've seen the Centaurs, AVS. We mentioned them; those good guys in
Right,
Air
they're
Mass. You've got Rick Webb at RD Webb has a smaller benchtop vacuum furnace. Who are the big guys? Is that like the Ibsens of the world?
Yeah,
the surface
there's
combustion.
Surface, yeah,
those
and
big
there's
ones.
Vac Aero, and
Okay.
but a lot of those are process driven. In my opinion, they're designed specifically for processes, right?
Okay.
I think, and I don't know what all these terms mean 100%, but calcining and
Mm-hmm.
they do annealing and
Mhm.
sintering at lower temperatures, and vacuum is used. Vacuum is a good thing for parts. And the reason why people use vacuum furnaces is because in air there are gases that are not inert. They're reactive. So if you're trying to heat a part up to higher temperatures to the point where you're going to get a reaction from oxygen or nitrogen that you can't tolerate, then you need to remove those gases. So that's why they would evacuate them.
Okay, so they don't make impurities in the
Right,
material.
in the material, right.
Yeah.
Or form different materials, like you can form nitrides and that kind of, or oxides, right, which you can take titanium and turn it into an oxide by heating it in air to a high enough temperature. You don't want that if you want it to still be titanium.
Okay.
So
Do you have the same restrictions of fitting on Route 95 in a truck? Because, I mean, a lot of things are designed because they have to get from point A to point B on a highway.
they got to fit in the building, or they got to get out of the building.
Right.
But those are easy things, I think, that you can overcome, because you can design your chambers in small enough pieces
so you can put them together
so you can put them together.
That's what I was going to ask. Can you put it together in the field? Yeah.
Right. I mean, it's not an easy thing. You need, a whole crew of people, right, to move
Cranes,
some of these.
probably.
Right. And a lot of those places that are getting that big equipment have that stuff generally.
I have seen some going by in trucks, but it's always that. I never realized that until one day somebody pointed it out, that everything goes out of this building. Everything you see had to fit in one lane, in whatever 95. And an American lane, not a French lane. I was in France, and those lanes are three-lane highways. They're as big as my small driveway.
Yeah.
These are American highways. So, cool. Andy, another question?
Yeah, here's a curiosity. Do you ever get into flexible vacuum molds? So I know one example is working with fiberglass. You'll pull a vacuum on it with a
Right, you heat up the plastic. That isn't anything that we generally get involved in.
That's thermoforming, actually.
But we really, like I said, we work at temperatures 1,000 degrees C and up, and that's really, there's a lot of players at the lower temperatures, hard to compete, right? So we tried to find a niche that we work in at the higher temperatures, stuff that people don't want to do.
Right.
I don't mind going out on a limb with somebody and
Right.
doing something crazy. That's always fun,
Yeah, and you guys are always in C.
Right.
Because otherwise it'd be 5,000, which sounds more impressive. When I go home and tell my family, I'm up to 5,500 degrees today, I'm bragging because it's Fahrenheit, but it's really only 3,000.
Right.
We're at a customer, so we have a high temp furnace, and well, how hot is it? It's 1,800 Fahrenheit. Yeah, that's not hot.
Well, and it's funny, 3,000 C for years. I've been building 3,000 C furnaces. I would say 90% of them don't get used at those temperatures. A lot of times they're bought for bragging rights.
Oh, really?
I got a 3,000 C furnace, and all of a sudden this professor at this university says, well, I got to have one.
Really?
So it's...
Oh, that's funny.
You get that kind of competition going on, yet there really isn't much to process up at those temperatures, but up until recently, they're starting to develop new materials, new purposes.
Yeah, I mean, infrared is one of the few ways to look at the temperature at that, and we're into that. And, the higher you go, the more problematic it is to calibrate an infrared sensor, because it's a very expensive calibration tool, or it has to make trips to the factory and back occasionally. So, yeah, it becomes an issue of calibrating. So you don't want to go too high, because the higher you say you're going to go, the more expensive it is to calibrate that thing. So, no, very good. You got one more?
That's pretty much it.
That was it? Okay. No, this is great.
Well, and one thing I would like to say, you're talking about temperature and worrying about calibrating pyrometers, right? One of the things I find very interesting is that vacuum sensors, right? They're just as important as the pyrometers in a lot of cases. And what I find very interesting is that in the lower in pressure you go, the more expensive the gauges become, which is probably fits with thermocouples and pyrometers, right?
Should be selling those.
But, and I apologize for letting this cat out of the bag, but if you look at the accuracy of these vacuum gauges, when you're down at 10 to the minus 5, 10 to the minus 6, some of the sensors, it's plus or minus 50%.
Wow.
Although 50% of nothing is half of nothing.
Right. So it's a lower number, right?
Right.
So
I mean, it isn't a big number to begin with,
right.
but the tolerance is, I mean, the accuracy is huge.
How's the repeatability though?
Oh, I think that's much better.
Yeah, that's the same with infrared. I mean, it's absolute is evasive, but repeatability is the holy grail.
But the other thing too is with a vacuum gauge, you spend a lot of money to measure nothing.
True. Yeah, people. That's true. I never thought of that. The like even with infrared sensors, like, well, you're at 0.5%. Well, 0.5% of 2,000 is like 12 degrees. Like, that's and for some of the new evolving technologies out there, 12 degrees is too much.
Well, that might be, but so far what I've seen in terms of some of the requirements, they're not as at the higher temperatures. They're not as stringent.
Got it. Okay.
As to what they require for the uniformity, let's say.
Right.
Probably partially because it's so difficult to check it.
Right. Yeah. How do you know? Put your finger in there.
Well, yeah. One of the things that we traditionally do is we use the temperature control rings. Granted, they don't go to high enough temperature, but generally what we found is that using them at the temperatures that they're designed for will give you a pretty good. And
I don't know what is that?
It's a ceramic ring.
Okay.
They're made by Shoop, makes some. PTCR. They look like a lifesaver.
Okay.
And they're one use. And they come with a chart that tells you, you measure, they're designed to a certain dimensional tolerance. And when you heat them up to a certain temperature, they're going to shrink. And then you measure them after you heat them up. And then you look at the chart that tells you what the temperature is.
Really? So are they small like a lifesaver?
They're exact. They look just like a lifesaver.
Anybody ever try to eat them?
No, not that I know of.
So I guess I don't know what I am, but my mind goes in various places really quick. But you reminded me of a story that's not related, but was related. We're in Portofino in Italy on a vacation, and there's a bowl of mints, in this right where we check in, and I go to grab one and put it in my mouth, and the guy almost tackles me in Italy. He's like, and I go, what's the matter? So he takes what I thought was a mint. I mean, the thing was like a lifesaver, right? And he gets a glass of water, takes this thing, he drops it in a glass of water, poof, it turns into a towel. Like, I am so glad I didn't swallow that.
Yes.
So, but again, I chased the rabbit. But no, Joe, and anything else you'd like to say? Any parting words? Any words of wisdom? It can be about Oxy, it could be about vacuum, or it could be about a mountain you want to tackle.
I guess that's an overload question. Yeah. Too much to think about.
Too much to think about. Okay. So when are you going to do Mount Washington? You've done Mount Washington.
I've done Mount Washington.
How hard was that?
It wasn't too bad. I mean, because of my physical limitations, I am very cautious about what trails I hike. And typically most mountains have more than one. Okay. And if I can't make it up one, I'll try another.
Okay.
And Mount Washington, I know, for me, would be difficult going up Tuckerman's Ravine and over Lion's Head and all that. But there's a beautiful trail on the other side of Mount Washington, on the west side, called the Jewel Trail.
Did that go by the Cog Railway?
Yeah.
Did you moon people when you saw that? I got mooned
I'm
on the Cog, and I got all these hikers are going up there, and they hate people in the train, and they moon them. So yeah, I thought it's pretty. I felt embarrassed to be going on a train up to that mountain, But also, I hated it because you get up there and there's cars and.
Yeah, I mean, Mount Washington is very commercial.
It is. It's terrible.
It's too bad.
It is. So, okay, well, hey, thank you so much for being here. I really appreciate it.
Oh, you're welcome.
And it was great. It was great having this conversation.
This is done already?
We're done. Yeah, I'm already getting the sign. We're over 30 minutes.
Okay.
Yeah, we got to keep it to a 35-ish time frame, and it didn't feel that way because it was fun.
It didn't.
So thank you, Andy, for your questions. Hope you find this informative and fun. And if there's any questions you have for us or even for Joe, you can contact us. Please feel free to share this when you see it on LinkedIn and any social media platform, and we can get a hold of Joe. You can figure out how to get a hold of him as well. Thank you for taking your time with us. We appreciate it.
Oh, you're welcome. Thanks for having me. It's fun.
Yeah, awesome. Thanks. And your grandkids will think you're cool. So, bye-bye.
See ya.
Thank you for getting in the loop with us. We hope this podcast was informative, and if you need any assistance on anything in the thermal process industry, please feel free to reach out to us at 800-848-NETS. That's 800-848-6387, or visit our website at www.nets-inc.com to fill out a request for information form. If there are any topics regarding thermal processes that you would like to hear on a future podcast, please send us a comment. We hope you have an awesome day every day.